Okay, so hello everyone, and welcome to the week number 4 tutorial problems for the machine and mechanism A. So once again, just remember that these videos are not official for your subject. It's only going to be about support material that help you to make a review for the next assessment or next quiz or the quiz. Okay, so we are going to start with the first problem, which is going to be about pendulums. So in this pendulum that consists of the 5 kilogram plate at the bottom, as you can see here, and 3 kilogram cylinder rod. So, okay, now we have the rod and we have the cylinder. Each one is going to have its mass and everyone is going to have its own length. So mainly we're going to consider that going in 2 dimensions only, so we don't worry about, for example, the width of the rod or, yeah, maybe the width of the rod or depth of the rod. So we need to find the radius of gyration of the pendulums about the axis that perpendicular to the screen and passing through the point G. Okay, so we want to find the radius of the gyration, sorry, for the pendulums about the axis that passing through the point G, where my red point is now. Just imagine that there's a pin going towards your screen, and that will be the axis we're looking for. So now the plan is to mine the MMI for all the pendulum first and using the method of the composite bodies. So again, divide it into the block and the rod, and then determine the radius of the gyration using the MMI and the mass value. So the solution here is going to be actually done in multiple steps, and you consider that as a procedure to do this calculation. So first we're going to separate the pendulum into a square plate P and the cylindrical rod R. So we going from there, and what you can see on the side here, I had the free body diagram for this step. That's the rod, and that's the plate. And this will make it much easier for us because now we know where's the center of the gravity for the rod, which is going to be in the middle of the 2 meters length. So this makes it at 1 meter length. And it's have its own mass, which is mass 1. For the block, it's going to be in the center of that block, and it's going to have the mass 2. Okay, so this was the first step. The center of the mass and the plate of the rod are going to be 2.25 and 1 meter from the point O respectively, right? So you can see that this is the point O, so the center of the gravity for, or center of the mass for the rod is going to be at 1 meter below. The center of the gravity for the block is going to be 2 plus 0.25, so it's going to make it as 2.25 from there. Step number 3. So the center of the gravity for the whole object should be equal to, now the y bar j is equal to the sigma of the y multiplied by the m divided by the sigma of the masses. So this will be the sigma of the individual center of mass multiplied by the mass of the body divided by the sigma of the masses for all the bodies. So in that case, what you can see here that 1 times the 3, 1 times the 3, because the mass of the rod is 3, plus we have the 2.25, 2.25, this is from the O to the point G2, multiplied by the mass of the mass 2, which is 5 kilograms, and then divided by 3 times 5, which is 8. Okay, so this will be the step, and we can find that the center of the gravity, or the point G that we show here, the y bar, is going to be equal to 1.781 meter. Okay. Now, third, the MMI data of the plates and the cylinder rods are given on the inside cover of the textbook. You can check that. Using these data and the parallel axis theorem, we're going to do the calculation to find the I. So the I for the whole thing, or the pendulum, is going to be the IG1R plus the MR multiplied by the D of the G1 minus the G minus G1 square. That's what we call the parallel axis theorem. It was explained in the lecture, so that's why I don't want to go through it once again. So let's see what we're going to apply here. So the first one, the I for that shape, which we're going to consider it as a rectangular shape, is going to be equal to the width multiplied by the height squared divided by 12, plus the mass of the rod, which is 3, multiplied by the distance was 1.78 minus the distance of the G1 or the Y bar minus the Y of the rod, which is 1 square. And this will give me that the answer is going to be equal to 2.83 kilogram meter square. Now we're going to do the same thing for the pendulum. Okay, so now once again for the pendulum, we're going to have the values to be calculated here with respect to the G value. So what we're going to have here is the mass is 5, okay, multiplied by 0.5 square plus 1 square and divided by 12, plus the 5, which is the mass, multiplied by 2.25, which is the distance from here to here, minus 1.78. So well, this is 1.78, and we have 2.25. We're going to find this distance, and then squared. Doesn't matter if it's going to be negative or positive because it's going to be squared anyway. So we'll find that the IGP is going to be equal to 1.62 kilogram meter square. So the total is going to be just adding both, and we're going to get the answer to be equal to 4.45 kilogram meter square. Now, this is for the composite bodies, and we got the answer for the IG as requested. Now, we can simply find the radius of gyration, which is going to be equal to the I divided by the mass on the square root. Now, total mass is 8 kilogram. The radius of gyration is going to be equal to the 4.45 divided by 8 on the square root, and this will give us 0.746 meter. That's it. That's how we find the radius of gyration for composite bodies.